Hair looks good. No. All right, better get started. 5, 4, 3, 2, 1. Good morning, everybody. Welcome to a rainy Tuesday morning of Chem 1105 with your host, me, Dr. White. Hi, everybody. Right, couple quick reminders. Remember, tomorrow, Wednesday, after lecture, I will be sending out the password for the PDF file that's password protected for test 3. And again, tomorrow, test 3 will be online. Here's the information. You got an email. I've gone through this. Just a reminder, test number 3 will cover chapter 6, which is gases, and chapter 5, part 2, which is solutions. And the points, it'll have 9 pages with 5 multiple choice, and some of the questions are multiple part. We'll have 48 points on gas, 57 on solutions, a total of 105, 5, yes, 5 bonus points. Remember, if you don't upload it as a single PDF file, I reserve the right to subtract up to 25 points if you don't do that or get things on time. And here's the information when you'll see test number 3 score in Blackboard and the individual answers, points you got. I'll send out an email before next Sunday. And next Monday, I will go over test number 3. I'll cut it out of the video. However, I'll post a private video and I'll send you the URL for that video so you can see it if you want to. And I already did yesterday the review. Also, let me remind you, this Thursday, end of the day, that will be the deadline for any past due labs that you can upload now through Thursday under the amnesty program so you can get some points. Instead of getting 0, you can get some points. Speaking about points and zero, when you take test number 3, show your work. I'll say that again in slow motion. When you take test number 3, show your work. If you make a math error and you don't show your work, you'll get 0 points. Yep, big Z-E-R-O, 0. If you show your work and you make an error, I can say, oh, you made a math error, you made an addition error, or this error. You can get partial credit. Show your work always on a test. All right, those are announcements. As keeping with my new policy, I'm going to do the lab first, and then we'll go back to the chapter 7 on acids and bases. Now, today's lab is going to be really exciting. You're going to be doing what? Well, let's take a look. You're going to be engineering a better airbag. I think you're all familiar with, and let's take a look. And here they show the car airbag, which is a safety device. I have one, hope you have them in your cars too. And on impact, they inflate. And they do it very quickly. You can look up videos trying to see if they show. Nope, I thought I'd see makeup what it is. But anyways, let's try one more. Nope, can't find it. But anyways, God forbid you're not to bring religion into the class, but if you're ever in an accident, which I haven't been, thank goodness, and hopefully you won't, but on collision, if you're on the driver's side, there's an airbag that inflates very quickly, like I guess instantly, and it protects you from being killed, stops you from going into the steering wheel. Even with safety belt, which I always wear and you should, it's still an extra safety feature. Same thing on the driver's side. In the back seats, they have them too. How does that happen? What causes that bag to inflate? Oh, I got a quick idea. Let's see if we can do it. Nope, that's not what I want. Let's try this one. No, I don't want a commercial. Sorry about that, but I'm not going to pay for commercial-free stuff when I can wait a few seconds. See how quickly that deployed? Let's do it again. Within a second or two, that deployed. That's not what I want. All right, so you'll be investigating a better airbag. You'll be using the equipment and chemicals from your kit. Don't forget, wear goggles, wear gloves, and you should wear an apron. All right, let's talk about this. When you fill up the gas bag, what are you filling it with? Gas. And you learned about the ideal gas law. And the ideal gas law is PV equal nRT, where P is pressure in atmospheres, V is volume is in liters, N is the number of moles, R is the universal gas law constant, and temperature is in Kelvin. Now, in a gas bag, the reaction they use is sodium azide, NaN3, is immediately reacted to give off sodium. Yeah, it's dangerous stuff, but nitrogen gas. And that's what fills up the bag very quickly. Now, because sodium metal is dangerous stuff, I've worked with it. What they do in the bag, there's also a small amount of ferric oxide, Fe2O3, otherwise known as rust, and that reacts with the sodium to form sodium oxide, which is safer than iron. Now, because sodium azide is very toxic, especially if you have cars that are now junked, the airbags are undeployed, that stuff's sitting in there. Thousands of cars, that's a lot of sodium azide. So what your job is today is to find a better chemicals or chemical reaction that will fill an airbag to save people's lives. Now, in this lab, you will be working with vinegar and baking powder. And in your kit, got a nice bottle of Heinz vinegar. We'll talk more about vinegar later in the semester. And baking powder. Arm & Hammer is probably the most famous brand. And this is sodium bicarbonate. This is in your kit. Also in your kit, you'll find 3 of these Ziploc bags that are, to fill it up properly, 1.2 liters. Now, what you're going to be doing is making a little indentation. I can't do it now easily, where part here you'll put the sodium bicarbonate, here you'll put the vinegar. You'll have a sort of indentation like this. When you put it in, you'll seal it, shake it, and time how long it takes to inflate. Or just watch how long it takes to inflate. And here's the equipment you'll use. Use the weigh boat and your scale to measure out the sodium bicarbonate. Use a plastic spoon to put it in there. And use your graduated cylinder to measure out the milliliters of your vinegar you'll be using. Now, the reaction you'll be doing in part 1, activity 1, you're just going to be doing some calculations. Again, activity 1, you'll be doing calculations. And here they have a step-by-step. First step, well, when you do it, you're mixing NaHCO3, sodium bicarbonate, that's the baking soda. And this CH3COOH is acetic acid. Now you can write it differently, and you'll see the way I have in a hand sheet I made for you. I have CH3CO2H. Now, acetic acid, this right here, in water is called vinegar, and it's a solution, and it comes in a certain molarity, which hopefully you learn about or learn for tomorrow's test, and you'll be doing certain calculations. Now, for this one, for the bag, It's 1.2 liter volume. Now, let's take a look at something I just created. And it's something you can download. And let me make sure you can see it. All right, if you go to the lab assignment on Blackboard, you'll see Engineering a Better Airbag, Dr. White's help sheet. Don't tell anybody I'm being nice. Shh. Don't tell anybody. All right, now in activity 1, you're going to use PV equal nRT. I've shown you, I won't show you how to do this. You can figure it out. You're going to solve for N. 3 dots means therefore N equals PV equal RT. N is the moles of CO2 you need to fill the airbag. Now in our lab, our airbag initially is 1.2 liters. Now to use PV equal nRT, you will have to have PV and T in the proper units. Now, you're going to use your thermometer to measure the room temperature, the temperature in the room. And from the internet, you will get atmospheric pressure. Let's look how you can do that from the internet. Now, my favorite place on the internet to get my weather information. I no longer watch TV. Years and years ago, when they didn't have the internet, yeah, I'm that old, you'd watch TV and they'd have the weather forecast on the 10 o'clock news and the earlier news on TV. Well, you don't have to do that. I like the weather underground. You can use whatever you want. Here I live in Schaumburg, so the Schaumburg station has this information. And if you scroll down, you'll see pressure. And that's the barometric or atmospheric pressure. 30.15 right now. It's raining out, so it's a lower pressure than normal atmospheric pressure. And notice it's in inches, really inches of mercury. And that's where you get the barometric or atmospheric pressure. When you do the lab, go online, put in your zip code right up here, search locations. Let's see. Nope, that's not what I wanted. And if we do Glen Ellen, Illinois, if we were at COD, I'd be doing this if we were in the lab. And you can see right now, it's about the same barometric pressure. Now, that you'll need in temperature. For activity 1, temperature should be in Kelvin. Well, you're in degrees C. You'll measure it at 273, write that in the table. Now, the pressure in inches, you need actually for PV equal nRT, pressure in atmospheres. So how do you do that? You take the pressure in inches of mercury, like you saw, I just got from Weather Underground, multiply it by 25.4, then divide it by 760. And that will give you the pressure in atmospheres. Now, N is the number of moles of CO2 you'll need to fill a 1.2 L's liter bag. And for this part 1 activity, V in PV equal nRT equals 1.2 liters. Calculate N using the correct value in units for T that you measured here, for the pressure here. And that will give you the moles of NO2 generated. Now, the reaction you're going to be doing, and this is cool, when we get to the part in chapter 7, I'll tell you a personal story about me and this reaction. When I was 5 years old, 5, I was already doing chemistry. And here you have acetic acid, and I'm writing it as CO2H instead of COOH. I'm an organic chemist. I like writing it this way. Sodium bicarbonate, your baking powder. Now they show three reactions. The second one in here is carbonic acid. And carbonic acid breaks down immediately. You can't isolate it in water to water and CO2. The CO2, carbon dioxide, is given off as a gas. You can either put G in bracket, or I like the little arrow, so I use the little arrow. I think it looks cooler, doesn't it? It looks cool. And that's what's filling up the bag. Now, if you notice and remember, you learned for test 2, the coefficients of a balanced chemical equation give you molar relationships. And notice all the coefficients are 1. And for every 1 mole of acetic acid, you'll make 1 mole of CO2. For every 1 mole of sodium bicarbonate, baking soda, you'll make 1 mole of CO2. So in order to determine the number of moles and therefore the number of grams or milliliters of either milliliters of a vinegar or grams of the baking powder, you do the following. Note, you'll need, since 1 mole of CO2 needs 1 mole of the acetic acid and also 1 mole of the sodium bicarbonate, you'll need N moles, which you calculated using this equation right here, N equal PV equal nRT for these values, to determine the number of N moles calculated using the ideal gas law, see above, to determine the milliliters, the amount of milliliters of vinegar. Remember, vinegar is acetic acid water you'll need. You do the following calculation. N, which you calculated from this calculation, number of moles of CO2, which is also the number of moles of acetic acid, you'll multiply by 1,000, divide by 0.833 moles of acetic acid. And where do we get this number? This number is the molarity. The vinegar is 0.833 molar acetic acid. And that's where this comes from. And we did that in solutions. And that will give you, when you have to do the calculation, the milliliters of vinegar you need. Now, the amount of grams of sodium bicarbonate, your baking soda, remember this is your vinegar, this is a molar solution, 0.833 molar solution of acetic acid in water. And to get the baking powder, remember 1 mole of carbon dioxide, you need 1 mole of sodium bicarbonate. So you start out with N moles of sodium bicarbonate. The N comes from this calculation for equal to N moles of CO2, carbon dioxide. You'll multiply times the molecular weight of sodium bicarbonate per 1 mole, and that gives you grams of sodium bicarbonate. You learned that for test 2. Now, once you get these numbers, the milliliters of vinegar needed, grams of sodium bicarbonate, you'll weigh out those grams in a weigh boat. There we go. So once you've done the calculations for activity 1, You'll fill in the room pressure and the atmosphere's temperature, moles in. You can write the balanced chemical equation. I gave it to you if you were watching it in my help sheet. And the mass of the sodium bicarbonate, I just showed you how to do that, and the volume of the vinegar. Now that you have the mass of the sodium bicarbonate and the volume of vinegar, you're going to do activity 2. And what you'll do is you'll weigh out the the sodium bicarbonate in a weigh boat. You'll measure out the milliliters of vinegar. Then you'll open up your plastic bag and you'll form the valley like they show you in a peak, see figure 1, and add the sodium bicarbonate first on one side of the valley. You got 2 valleys, one side and the other. Remember, it will be like, wonder if it'd be easier. Nah. Once you get the sodium bicarbonate in, this side you put that, the other you put the bicarbonate. And here they show you how to do that. You can put it on the edge of something. I don't know. You can take something like this. By the way, this is one of my high-tech flashlights from a gentleman, Hank Wang in China, who makes the best flashlights in the world. All right, then you'll pour the vinegar on the other side of the valley and don't mix yet. Carefully seal the Ziploc and try and push out all the air without mixing yet. And then what you'll do, pick up the bag, tilt it, mix it, make sure the top is sealed totally. And then when the reaction is complete, should look like figure 2. Leave the bag inflated for the next 2 steps. All right, you're going to see how full this bag gets inflated. Now, for the next step, number 10, you'll repeat steps 1 through 9, except the amount of sodium bicarbonate, the original one you did in step 1 for the sodium bicarbonate you weighed out, you'll add an additional 0.3 grams. So if it was 1 gram in the initial step 1, you use 1.3 grams. And you'll put it on one side of a fresh bag. Good news, you're given 2 more bags to do the reactions. And you'll also, for the amount of vinegar, if it had, I'm just using a number I'm picking out of my head. Oh, I picked a number. Sorry for the bad joke. If it was 10 milliliters, you'll add an additional and you'll use now 15. And you'll do the same thing, put it in the valve, seal it, get the air out, shake it up, and see how much it's inflated. And then you'll repeat those same steps 1 through 9, but now instead of the original amount in step 1, you'll have that plus 0.5 grams of sodium bicarbonate. And step 2 of this activity, the original volume of the vinegar, so let's say it was 10, you'll add 10 more milliliters and you'll use 20. Same valley, put them in there, get the air out, seal it, mix it, and then you'll compare the 3 bags, which one is the fullest, which one is not, the least, and what's in the middle. Sounds like Goldilocks. Oh, this bed's too hard, this is too soft. Oh, this is too right. Sorry about the Goldilocks. Not really. All right, now in step 3, activity 3, they're asking you to just do calculations. And what they're asking you to do is do the calculations you did in step 1. But instead of using 1.2 liters for the volume, you'll use one calculation 80 liters and the other one 160 liters. And if we go to my help sheet, you'll see an activity, use the amount of calculate the amount of milliliters and all that to do this. Oh, I'm on the wrong one. Activity 3, redo the calculations for activity 1, but use the volume for 80.0 liters for table 3 and 160.0 liters for table 4. Now in table 2, you'll from activity 2 for the 3 different bags, how much grams of vinegar or sodium bicarbonate mils of vinegar you use. Observation. It was most bag with the greatest inflation or filling of CO2, the least, the better, whatever. Now in table 3, you'll put the moles of CO2, the balanced chemical equation, which will be the same as you wrote up here in table 1, and the grams of sodium bicarbonate and the vinegar. Remember, this is when the volume in PV equal nRT is 80 liters. In table 3, you'll do the same, except now the volume for PV equal nRT in the equation we did in activity 1 is 160 liters, and you fill in the results here, or the calculation. And for cleanup, dispose of all the solids you have, plastic bag, plastic, rinse the graduated cylinder a couple times, water down the sink, and dry it, and clean any leftover baking should be returned to the chemical kit. I don't know what we're going to do with it later. I think we're going to do another lab with that. So that's today's lab. Let's look at the actual lab report. The lab report, don't forget, you need a selfie of you doing one step or you get 0 points. That's the chemistry department's rules for online labs, and I follow them, and you should too. And for activity 1, we already showed you how to fill these all in. Activity 2, you just copy from the other one, and same thing for tables 3 and 4. The only question you have to answer is question 1, and answer it. And that's due a week from today. And that's today's lab. We have a lot of fun working with this and doing that reaction, reacting acetic acid, vinegar, acetic acid, and water, sodium bicarbonate, otherwise known as baking soda, and I'll talk more about it. All right. Let me clean up some of my space here. And now let me close a few things. Remember, in the lab assignment area, you'll see where I just posted the help sheets, and they'll help you. Also remember, if any lab, if you have any questions, I haven't said this in a while, there's no such thing as a dumb question in my class or my universe or my world. I guess they're the same. But if you have problems, email me. If you have problems, come after class and see me. Or if you have problems, come to my office hours. I'm always available to help you. Lab or anything else with Chem 1105. All right, let's get back to material that will be on test number 4. Now, yesterday, we were talking about acids and bases, and remember, an acid, proton donor, base, proton acceptor. Now, it turns out not all acids and bases are the same. And what do I mean by that? Well, let's look at a general equal reaction of an acid with a base. And here we have an acid reacting with a base, proton transfer, and you get the conjugate base of the acid and the conjugate acid of the base, A minus HB plus. Now, this is an equilibrium. In this class, we don't teach equilibrium reactions. I do in Chem 1211, which I teach also at COD some semesters. But that means the rates are going back and forth at the same time. Now, in real life, not all acids and bases are the same. Let's just do a simple acid. If it's a strong acid, and let's simplify the equilibrium, it goes mostly to the right, and a little stays on the left. Now, if it's a weak acid, by the way, switches click off for this, but it's something you should know about. Very little goes to the right, and most of it stays as HA. And why should you know about strong and weak acids? Well, for your own safety is one thing. Now, strong acid, the equilibrium to the right, nearly 100% is transferred to water. I had water in there. Now, examples of strong acids are all halogen. Now, in organic chemistry, we use X for the halogens. So an example of HX would be hydrochloric acid. Another one is nitric acid and sulfuric acid. These are strong acids. Unfortunately, a number of years ago, I was teaching an organic lab at COD. Boy, hold on, I got to reboot. COD. And a student, unfortunately, didn't follow directions, safety directions, and got some sulfuric acid, concentrated sulfuric acid on his arm in my class. And he didn't follow directions. And I was there within 20 seconds or more, got him under cold water. And even that, it wasn't enough time for that strong acid to cause what's called an acid burn. Why is it called an acid burn? Because the damage it did to his skin on his forearm was the same if you took a hot piece of metal and put it on your arm. It burned it, destroyed the cells in the skin there. And he should have followed directions. Everybody else did. In fact, that's the only time I've ever had in all the years I've been teaching that lab, someone have an accident. And where you're pouring with an eyedropper using a funnel, he decided, well, this little hole here, I can put it in with the eyedropper. And he was nervous and whoop, shouldn't have done that. But anyways, that's a strong acid. Now, weak acids are substances that transfer only a small amount of protons to water. I guess I can re-amend what I had earlier on the whiteboard. Instead of this, I guess I should really have put this. And this means essentially almost most of it goes to the right. And for a weak acid, and this won't be on a test, but it's something you should know, it goes very little to the right. Most of it stays here. It doesn't donate much of its proton, just a little. I'm a weak acid. Here, just take a little of my protons. If I'm a strong acid, take all of my protons. Now, what's an example of a weak acid? Funny, you should ask. Acetic acid in water. This is a weak acid. You can use vinegar. You can use it for cooking. I do. I don't know about you, but I like to make, let's see, pickled onions, pickled carrots, pickled habanero peppers I've done, and pickled pickles, pickled cucumbers. That's one of my favorite. Oh, is that good? But if this were a strong acid, you'd be dead or in the hospital if you used it in your cooking. It's a weak acid, so you can use the acetic acid water known as vinegar. Oh, show and tell. Let me see something. Yep. Uh, reading glasses. Before I had my cataract surgery about almost a year and a half ago, I'd always be wearing my glasses except for reading. Now I don't need glasses except for reading. If you look real close, right here, you'll see a circle U, and that means this is kosher. Kosher is a standard, quality standard for certain foods for the Jewish religion. Muslims use similar, not same, similar, called and you can find that, and that means it's a higher quality in my mind. It follows the kosher laws. But anyways, that's a weak acid, that's a weak base. And similarly, you can have strong bases, which say, give me your proton. And those are mainly sodium hydroxide and potassium hydroxide, strong bases. Now, weak base, oh, another show and tell, sodium bicarbonate. And that's in baking powder. Ooh, and it's pure baking powder. Hold on 1 second. I've never done this before. And I thought it would be there. It is. Teaching you secrets of the world. If you look closely right here by the A, you'll see a circle U. That stands for Union of Orthodox Rabbis. And that means this is kosher too. Anything that has pork in it can't be kosher. It's part of the kosher laws. All right. Now, let's talk about water. Water is an amazing chemical. I bet you don't think of the stuff in this bottle as a chemical. It is. Now, it turns out water can react with itself. It can. And when you have two water molecules reacting, there's an equilibrium. Most of it is unreacted, but it's just a very tiny amount, an important tiny amount, reacts and there's a proton transfer. One molecule of water transfers its proton to the other to give the hydronium ion, H3O+, and hydroxide. Now, this very little goes to the right. That's why the arrow on top is tiny, but this is very important. Now, it turns out there's a constant, a number you can calculate that's called KW. I wish it was after me, Kenneth White, but it's not. This was long before I was born, this was discovered. But hold on one second, I got to turn something off. Now, the ionization constant, and if we were at Chem 1211, when we go over equilibrium, I can then show you how this is derived, but that's a different class, is the concentration. When you have something in a bracket, if you see bracket X, close bracket, and there's a number 2, that's the moles of X per 1,000 milliliters, the molarity. Therefore, Kw is the hydronium ion concentration, H3O plus, times the hydroxide. And this is equal to 1, I actually just should be 1.0 times 10 to the minus 14 at 25 degrees C. At different temperatures, it's different amounts. And this is something you should know. Know this equation, know the value. Listen to the old slide. You no longer have to memorize things in my class, not everything. And if you look at test 4, important information, you'll see I give you this right here. So that's something in the past, and this should be changed to 1.0, but it really doesn't matter. Anyways, this will be given to you. In the past, you'd have to memorize this. So this turns out to be very important equation, very important relationship, the dissociation of water. Goes on in the bottle of water I have here, goes on to water in my stomach, it goes on to water in your blood. This is happening everywhere. I told you chemistry is everywhere. Now, when we talk about solutions dealing with acid, bases, and water, we use the term acidic solution, basic solution, and neutral solution. And if I look at the clock, which I just did, let's take about a 5-minute break and we'll come back and do these. So let's take a 5-minute break and I'll be back in 5. Let's get back to work. All right, turns out, bad Dr. White, I jumped ahead a little. Let's go back to what we were talking about, and that's the dissociation constant of water, Kw, named after me, not really, I wish it was. And that's hydronium ion concentration, H3O plus times hydroxide equals 1.0 times 10 to the minus 14. And let's do some work with this, which I should have done before we got ahead. And let's take a look at this. If the hydronium ion concentration, remember in brackets, that means concentration, molarity, H3O constant plus concentration is 1.0 times 10 to the minus fifth, then what is the hydroxide ion concentration? So what are we trying to find? This. What are we given? And as soon as you see you're trying to find OH minus concentration, remember the brackets here mean concentration, molarity, and you're given the hydronium, you should remember, and this will be given an important information, test number 4, coming up in the future. The hydronium ion concentration times the hydroxide equals 1.0 times 10 to the minus 14. What are we trying to solve for? Hydroxide, OH minus. How do we get it alone on one side? Well, anything divided by itself, A divided by A, equals the number 1. So if I want hydroxide alone on one side, I'll divide by this side by hydronium. Whatever you do to one side, you have to do to the other. And I will. And here, anything divided by itself equals the number 1. 1 times something equals that something. In this case, hydroxide equals 1.0 times 10 to the minus 14th divided by hydronium ion concentration. What's the hydronium concentration? It's right here. 1.0 times 10 to the minus fifth. Get your calculator out, or remember this is, hold on, 10 to the minus 14th. And the answer here is the concentration is 10 to the minus 9th. Let me clean this up a little. And this is our answer. So let's go through again. What did I do? Well, here's the problem. If the hydronium ion concentration, remember H3O plus is hydronium. and OH minus is the hydroxide. Hydronium, H3O plus, hydroxide, OH minus. So if the hydronium ion concentration, H3O plus, is 1.0 times 10 to the minus fifth, then what is the hydroxide ion concentration? We're trying to find this, and we're given this. We're also given this Kw, the ionization constant of water. No, it's not named after me. Wish it was, but it isn't. And let me remind you, you look at important information, test number 4, not the one tomorrow, but down the road, I give you Kw, not me, the ionization constant for water, H3O plus concentration times hydroxide concentration. Remember, in brackets, that means molarity concentration is 1 or 1.0 times 10 to the minus 14. All right, let's let you have some fun. We're going to do this stepwise. I could have made this fancier. If the hydronium ion concentration, H3O plus, equals 1.0 times 10 to the minus 10th for a solution, then what is the hydroxide ion concentration for that solution? So the first thing I want you to do right here and here is, what are you being given and what are you being asked to find? What are you being asked to find? What are you given? All right, let's take a look. I'll give you another 30 seconds. See how generous I am? All right, so what are we being asked to find? What is the hydroxide ion concentration? What are we given? The hydronium ion concentration. Do we know a relationship between OH minus concentration, H3O plus concentration? And the answer is yes. If you look at important information, hydronium ion concentration times hydroxide ion concentration is 1 or 1.0 times 10 to the minus 14. So I now know this times this hydronium times hydroxide concentration is 1.0 times 10 to the minus 14. Well, what am I solving for? Hydroxide, because we figured that out right here. How do I get it alone? How do I get rid of H3O plus concentration? I divide by that, because anything divided by itself equals the number 1, cancels out. So if I divide this side, I should have let you do this. We'll do another one. By H3O plus What do I have to do to the other side too? Yes, divide it by H3O plus. Now this cancels out. I'm left with OH minus concentration hydroxide equals 1.0 times 10 to the minus 14th. Hold on. I can't draw 14 right. Okay, let's try it again. That's nicer. Divided by the hydronium ion concentration. I know this is still 1.0 times 10 to the minus 14th. And what's the hydronium ion concentration? It's right there. 1.0 times 10 to the minus 10. Got my calculator out. I can do this in my head. And there's your answer. Oh, by the way, how can I do this in my head? Before there were calculators, you needed slide rules, which I have one. Hold on one second. I'll be right back. It's going to be a special show and tell. It's show and tell. Now, because of the marvel, I think it is, and creativity and inventions of many people, you can buy a really cheap calculator like this that's very powerful for about $15. Now, until I got into my second or third year of grad school, that's a while ago, calculators were big and expensive, and you couldn't get a small calculator like this. The first one that came out, I remember I was in grad school my third year, somebody I knew got one, was by HP, and it was $500. Those dollars, which would be, I don't know, $4,000 or $5,000 today. Well, what did you use instead of a calculator? A slide rule. And this is one of my prized possessions. This is my slide rule. And this allows you to multiply, divide, and do other math things. Doesn't add, you got to do that in your head. And this was a fancy one because if you look right here, see the white right here? That's Teflon tracks. All slide rules, the good ones, are made out of bamboo because it doesn't swell with humidity, so it slides. This one I got, this was my high school graduation present from my parents. A wonderful gift. I think back then it cost about $50. And the salary my father was making, which was quite good at that time, was only about 18,000 a year. And that was a very good salary for anybody. And today's dollars, this would be a couple $1,000, maybe $1,000, $500,000 in today's dollars. And this got me through college and grad school. And it's my prized possession, one of them, great memories. But why am I talking about this? I thought I'd give you a quick thing. When you use a slide rule and you use powers of 10, this doesn't do powers of 10. You have to know how to do that yourself. And how do you do that? How do I do this real quick? You have 10 to the C divided by 10 to the D divided by 10 to the C. This equals 10 to the D minus C. And 14 minus 10, or minus 14 minus 10, and let me clean this up too, is minus 4. And that's how I can do that in my head. Because of the slide rule, you have to learn things like this for powers of 10. And the other one would be and if you multiply 2 powers of 10, 10 to the A times 10 to the B, the answer is 10 to the A plus B. But we're not doing it for this problem. All right, let's do another one of these, because it's an important skill to have. All right, let's look at this one. If the hydroxide OH minus concentration, remember brackets means concentration, moles per liter, it's 1.0 times 10 to the minus 3. On these type of problems, you don't put down moles per liter, but that's what it is. Then what is the hydronium ion concentration? So we're going to do 2 problems, and this time I'm going to let you have more fun. First of all, what are you being asked to find? What are you given? Your turn. And you're trying to find out, what are you being asked to find? What are you given? All right, what are you being asked to find? The hydronium ion concentration. What are you given? The hydroxide ion concentration, this. And you know a relationship between the 2 of these? And the answer is yes. If you forgot, you can go to important information, test number 4, hydronium ion concentration times hydroxide equals 1.0 times 10 to the minus 4. I'll correct that, make it 1.0. So we know this. We're trying to solve for what? The hydronium ion concentration H3O plus. We want it alone on one side. How do we get it alone? I'm going to let you try it first right here. What do you have to do to get rid of OH minus? Time's up. How do we get rid of OH minus? When you have 2 things multiplied, to get rid of one of them, you divide by that. because anything divided by itself equals the number 1. Whatever you do to one side, you have to do to the other. And if this cancels out, what do you write there? Your turn. We're doing this stepwise. And the answer is this. That. So now we want to solve to get this. What do? Well, we know the hydroxide ion concentration is 1.0 times 10 to the minus 3. So we have this divided by 1.0 times 10 to the minus 3, and that equals 1.0 times 10 to the minus 11. And that would be the hydronium ion concentration, H3O plus. Let's do one more. All right, this one I'm going to let you do stepwise on your own. The first thing we're going to do is, what are you being asked to find? What are you given? Your turn. Again, what you're trying to do, figure out what are you being asked to find? What are you given? All right, what are we being asked to find? Well, what is this? This is what we're being asked to find. And what are we given? This. Now, as soon as you see a problem with hydronium ion concentration, hydroxide, you should remember, and this is in test number 4, important information. The hydronium ion concentration, H3O plus, times the hydroxide equals 1.0 times 10 to the minus 14. Now, what are we trying to solve for? The hydronium ion concentration. What 2 steps do you have to do there and there to get that alone on one side? Your turn. And while you're doing that, I can get a fresh bottle of water, H2O. I'll be right back. But you should be working on, well, that's not what I want. You should be working on finding out how to solve for H3O plus. And I'll be right back. So work on that. Are you working on that? Fresh bottle of water, nice and cold out of the refrigerator. All right, and time's up. How do you solve for hydronium ion concentration? You want it alone on one side. So I have to get rid of the hydroxide. Remember, anything divided by itself equals the number one. It's canceled out. So how do I get rid of hydroxide on one side? I divide by it. Whatever I do to one side of an equation, I have to do to the other side. So I'll divide by hydroxide. This cancels out. I'm left with hydronium ion concentration, H3O plus, equals 1.0 times 10 to the minus 14th. Boy, I'm having a bad 14 day. That's better. Divided by hydroxide ion concentration. And now we know what this number is because we have it up here. And this is 10 times 10 to the minus 11. Do the math. And that's our answer. 1.0 times 10 to the minus 13th is the hydronium ion concentration. Now, question you should have in your mind is, why do I want to know these numbers? Well, it turns out there's a very important concept in our life. You've probably heard these words, but let's learn about what they mean. And that's acidic, basic, and neutral solutions. Now, we're talking about, when we say solutions, they're aqueous solutions, and you know this means water is the solvent. So when we talk about acidic solution, an acidic solution, by the way, the calculations I did before, you should know how to do. And I haven't been subtle all day, so I better do this. And know this. Hi, what's an acidic solution? An acidic solution is where the hydronium ion concentration is higher, greater than the hydroxide ion concentration. What that means is For acidic solution, H3O plus concentration is greater than, this means, if you don't know, that's the greater than symbol for math, and you can use it obviously in chemistry. So if you have the hydronium concentration larger than the hydroxide, it's acidic. Some of you probably know your stomach has acid and water in it. It's acidic because the H3O plus concentration is greater than hydroxide. Now, the next one you should know is basic solution. And a basic solution is a solution in which the concentration hydroxide ion is greater than the concentration of hydronium. So for basic solution, you should know hydroxide concentration is greater than hydronium ion concentration. Now, basic solutions are sometimes called alkaline solutions. Now, long ago, batteries used to be made with acid in there. And now batteries, which are called alkaline batteries, because they have basic solutions. In this battery, if I were to put it in water, the hydroxide ion is greater than hydronium. That's why it's called an alkaline battery. So basic solution, hydroxide greater than hydronium. And finally, we have a neutral solution. A neutral solution is a solution which the concentration of the hydroxide ion and the hydronium ion are equal. So for a neutral solution, this is true. So let's go through this again, but in an easier way to remember. And let me be subtle again. And know this. So for an acidic solution, the hydronium ion concentration, H3O plus, is greater than the hydroxide, OH minus, concentration. For a basic solution, hydroxide, OH minus, is greater than, that's what this symbol means, the hydronium ion concentration. For a neutral solution, the hydronium ion concentration, H3O plus, is equal to the hydroxide ion concentration. So, acidic solution, hydronium ion concentration is greater than hydroxide. Basic solution, hydroxide is greater than hydronium. And finally, a neutral solution, hydronium is equal to hydroxide concentration. And these are terms we use in our daily life. Is that acidic? Is that basic? Or is that neutral? Now, it turns out your blood is just about neutral solution. If it's acidic or basic, guess what happens? You're going to be in serious trouble or dead. Either one of those, not good. You want your blood to be neutral. The hydronium ion concentration equals the hydroxide. And there are ways your body does that. Now, if I look at the clock, it's time for a cliffhanger. It's about time to finish up. I think instead of going into the pH concept now, I will do it tomorrow morning when we have our next lecture. Now, I will tell you this, of all the things I'm going to teach you this semester, the pH concept is probably one of the most important and one of the most useful you will use the rest of your life. So you'll just have to wait until tomorrow to learn about it. And with that, let me remind you, tomorrow after lecture, I will be giving test number 3, sending out the password, and you'll have until Thursday, 1 p.m. to take test number 3 and upload it as a single PDF file. Remember, no multiple pictures. It's got to be a single PDF file. Oh, I can do that. Look out. You're getting sleepy. You're getting sleepy. No. But anyways, you will study for test number 3 today and tomorrow morning. You'll do the practice problems. Did that work? I hope it did. Also, don't forget, the lab we did last week is due today. The lab we did last week, I think it was 2 labs, but they're due today. And finally, the lab we did today is due next week. Remember, the amnesty program for past labs that you haven't handed in is due, is the deadline, is this Thursday, end of the day. So make sure you do that. And don't forget, last thing, tonight, Tuesday and Wednesday night from 6 to 7:15, I have my office hour. If you want to stop by and say hello to me, please do. If you need any help, please stop by also. With that, I'll say, gang gesund, goodbye. I stole that from Granny to Beverly Hillbillies. Bye. Gang gesund.